Organic farming and agroecology constitute a collection of alternative agricultural practices that attempt to address the negative impacts of large-scale industrial agriculture. While the primary purpose of organic farming seeks to preserve soil fertility and minimize environmental impacts, agroecology practices address a wider range of ecological, social, and economic concerns with an integrative and transdisciplinary approach. Organic is by far the most recognized form of alternative agriculture. The USDA defines it as food that is produced without using most conventional pesticides, without fertilizers made with synthetic ingredients or sewage sludge, without bioengineering, and without ionizing radiation. As far as animals are concerned, they must be raised under organic practices and be given organic feed and allowed access to the outdoors, and they cannot be given hormones or other growth-promoting drugs. The USDA label or seal recognizes 3 categories of organic food and non-food products. These include a 100% organic seal, an organic seal where products contain a minimum of 95% organic ingredients, and a made with organic claim where a product must contain a minimum of 70% organic contents. Here's a table that outlines USDA organic labeling requirements. The takeaway here is that products that have less than 95% organic ingredients cannot use a USDA organic seal, but they can claim to be made with organic ingredients. To maintain soil fertility, organic farmers depend on strategies such as crop rotation, cover crops with nitrogen-fixing legumes such as clover and alfalfa, and they can also apply compost, which can be green compost, which is when plants are mulched, and also manure. To reduce the incidence of pests, weeds, and diseases, organic farmers use diverse planting and employ approved pest control products. These products can include natural but toxic products such as rotenone, copper, nicotine sulfate, and pyrethrums. Once sold as specialty products at health food stores, organic produce saw a marked rise in sales in 2002 when USDA's National Organic Standards created an organic seal and label. Since then, organic produce, dairy, and meat have captured higher premiums that can be translated into profits of 20 to 30%. This chart shows that since 2006, organic products maintained a double-digit growth rate. In 2015, organic food sales were $39.7 billion, or nearly 5% of all food sales in the United States. And it should be noted also that non-food sales, such as soaps, makeup, and cotton, have all experienced a steady growth in sales, now in the billions of dollars. This chart shows the growth of organic foods from 2005 to 2014, broken down by food category. Fruit and vegetables take the largest share, followed by dairy, beverages, and packaged foods. In 2013, the U.S. was the largest market for organic food, with sales larger than that of Germany, France, China, and Canada combined. USDA organic practices can offer many ecological and health benefits, including reduced chemical contamination of air, water, and soil, as well as a reduction of pesticide exposure for farm workers and wildlife, including pollinators. Organic practices also reduce pesticide residue in food. However, the causal link between chemical residues and diseases such as cancer have been difficult to prove and are still actively debated. Organic agriculture has received its fair share of criticism over the years. For example, well over half of the market is controlled by large industrial farms that meet the USDA organic standards, but share little in common with the small-scale organic farmers that began in the 1960s and 1970s, including, some claim, the social and environmental principles of that era. To help illustrate the high degree of consolidation that has impacted the organic food industry, Phil Howard, an associate professor at Michigan State, has created a Who Owns Organic chart that can be found at cornucopia.org. This chart does a great job of showing how parent companies have been snapping up smaller organic companies. Here we see General Mills and what they've done. There's also Post Foods and even Coca-Cola. And and Nestle. Check out this chart. It's quite impressive. Another criticism of organic relates more to the USDA label, which is considered big business friendly because small farmers don't have the means to comply with record-keeping requirements or the money to pay for the fees for the USDA labels. Also, some smaller businesses decide to forgo the cost and hassle of the USDA label because terms like pesticide-free and natural are unregulated and can be used to make marketing claims. Another criticism, interestingly, has to do with the toxic hazards posed by organic farming. It turns out that some natural pesticides are fairly dangerous, and because they are approved, they can be applied in large quantities. For example, pyrethrin, an organic compound derived from the chrysanthemum plant, is a potent insecticide because it targets the nervous system of insects. Another criticism is that organic food is as energy intensive as conventional farming because it uses the same mechanized methods to irrigate, propagate, and harvest crops. This critique speaks to a 20th century agricultural trend where energy inputs have outstripped increases in the energy output of food. As shown in this chart, energy inputs have tripled between 1940 and 1970, while food calories have increased by less than half. According to the food author, Michael Pollan, for every calorie of food that is produced in the United States, 10 calories of fossil fuel energy are put into the system to grow that food. But wait, you might say, doesn't organic farming forego energy-intensive pesticides and fertilizers? Which brings us to our next slide. This criticism asserts that there isn't enough forage land for truly organic agriculture to exist. This technical concern points out that organic farming relies heavily on indirect inputs of synthetic fertilizers to grow the forage, to feed the cows, to produce the manure that fertilizes organic farming. The argument goes that without synthetic fertilizers, more cows would be needed to produce nitrogen fertilizers, and an impossibly large amount of land would be needed to grow forage to feed these animals. Here's a quote from the book Food Politics by Robert Paulberg, who references the agronomist Václav Smil. The quote goes like this: "Synthetic fertilizers support about 40% of all nitrogen used by crops around the world. To replace the synthetic nitrogen with organic nitrogen, it would require the manure production of approximately 7 to 8 billion additional cattle, roughly a 5-fold increase from the current number of 1.3 billion cattle. The United States alone would have to accept nearly 1 billion additional animals and add 2 billion acres of forage crops to feed those animals, equal to all the land in the lower 48 states. As this slide shows, the lower 48 states hold about 64 million forage acres, putting the 2 billion acre requirement in stark contrast." This concern about the global limits of resource depletion brings us to the promise of agroecology, an agricultural approach that takes into consideration a broader range of concerns beyond that of soil fertility, including the long-term sustainability of the food system. More specifically, agroecology is defined as the integrative study of the ecology of the entire food system, encompassing ecological, economic, and social dimensions. Agroecology encompasses the complexity and the challenges of increasing food production while achieving long-term sustainability for the food system. Here are some agroecology examples, including permaculture, perennial polyculture, biodynamic farming, and agroforestry. I'll let you read the definitions. It is important to think of agroecology as part of a continuum of practices that ranges from conventional farming with intensive chemical inputs to a self-sustaining and regenerative model. This continuum has also been described as a series of stages that move from conventional intensive farming that adopts increased efficiency, then input substitution, followed by a deeper system redesign that leads ultimately to a sustainable food system. This diagram provides another model that explains the relationship between agricultural productivity, the y-axis, and sustainability, the x-axis on the bottom. Here we see that productivity initially decreases as conventional farming transitions to low-input farming methods like organic farming. Then, as higher yielding agroecology practices take hold, with the help of state support, productivity increases. This is a hopeful picture that relies on reports that permaculture is not only low impact and self sustaining, but highly productive. While permaculture gardens are beautiful and intriguing, the number of controlled trials and experiments that measure productivity are few. And even if permaculture gardens do work well, can they be scaled up to feed billions of people? This is essentially the same question that faces all of agroecology. In closing, let me make a few food analogies to describe the difference between conventional and organic agriculture. Conventional agriculture seems like a large can of soda to me. Society would be better off without it, but we're hooked in a big way. Meanwhile, diet soda offers a clear but limited benefit, low calories, just like organic agriculture addresses a critical but limited set of concerns, soil fertility and reduced use of toxic substances. The world will not become healthy by drinking diet soda, nor will a global shift to organic agriculture make the food supply or food system sustainable. I've also added a small glass of water to represent agroecology, not only because of its purity of purpose, but because of its diminutive capacity. We all would be better off drinking more agroecology water, but in this case, not much is available.